Hello, today I'll present S-Graph Plus, real-time localization and mapping leveraging hierarchical representations. Several works in the state-of-the-art like scene graph fusion generate 3D scene graphs in real time, but do not utilize this graph to optimize the underlying robot poses to improve the graph generation. Neither can they provide more enhanced relationships like rooms and its corresponding objects. Works like Hydra generate 3D scene graphs in real time, extracting additional features like rooms and connecting them with their underlying objects. However, Hydra does not continuously optimize the 3D scene graph, and it only does it on detection of appropriate loop closures, which is not possible in experiments where robot does not revisit a given scene. Our previous work, Situational Graphs, presents for the first time a tightly coupled SLAM graph and a 3D scene graph in a factor graph formulation, continuously optimizing it. However, the room detection algorithm is based on simple heuristics and does not generalize to complex indoor environments. It also required a better formulation between the semantic relational constraints in the factor graph, as well as extraction of additional semantic relations like floor and its corresponding rooms. Thus, we present S-Graph Plus, which jointly optimizes a slant graph and a 3D scene graph in 4 layers. S-Graph Plus consists of keyframe layer with robot pose estimate, wall layers representing the wall surfaces, rooms encompassing the set of wall planes, and floor layers gathering the rooms at a given floor level. We present a novel room and floor segmentation algorithm to extract these higher level entities. S-Graph Plus, through experimental validation, outperforms the second best method by a margin of 10.67%. The front end of S-Graph Plus consists of a robot odometry generated by either robot encoders or 3D LiDAR measurements. A plane segmentation module extracting all the wall planes from point cloud snapshot at each keyframe. A room segmentation module utilizing free space clusters along with map wall planes of the latest keyframe to extract room centers. A floor segmentation module utilizing information of all the currently mapped wall planes to extract a floor center. And a loop closure module utilizing scan matching algorithm to recognize revisited places. Additionally, it has the backend which generates the 4-layer optimizable S-Graph Plus and continuously optimizes it. In case of room segmentation, we modify a free space generation algorithm to provide us free space clusters for given constrained spaces like rooms. Given a cluster, we check all the map wall planes by a keyframe at a given time. After performing some width and bound checks, if 2 pairs of opposed walls are found surrounding a given cluster, we denote it as 4-wall room, and its center is extracted using the 4 wall planes. On the other hand, if only 2 opposed wall planes are found, a 2-wall room is extracted and its center is calculated using the cluster center as well as the 2 wall planes. In case of floor segmentation module, all map wall planes in an environment at a given time instance are verified. The widest of the opposed planes, that is the X and Y planes, are then used to extract the floor center. A floor node connects all the underlying 4 and 2 wall rooms at a given floor level. We validated S-Graph Plus on different simulated, real in-house, and real standard datasets, comparing it with several state-of-the-art LiDAR SLAM-based approaches. In simulated experiments, we utilized 3D LiDAR odometry and tested it against 2 odometry methods, that is VG-ICP and FLOM, where you can see from table 1 that ours with VG-ICP odometry provides the best average accuracy in terms of ATE when compared with the ground truth. In real in-house datasets, we utilize robot encoders to obtain the robot odometry and compare the final generated map with the ground truth map to obtain the mapping accuracy. And you can observe from table 2 that S-Graph Plus is able to outperform the state of the art. In terms of precision, S-Graph Plus outperforms or provides similar results to S-Graph for room detection. But in case of recall for room detection, S-Graph Plus outperforms the baseline S-Graphs by a great margin, thus proving better generalizability in different environments. The figures on the right show the final map quality of S-Graph Plus when comparing it with the baseline in real experiments. Observe the cleaner map representation provided by S-Graph Plus. In terms of real experiments on standard datasets, S-Graph Plus is also validated for the two odometry methods, that is VG, ICP, and FLOM, and it outperforms on average the other state-of-the-art methods. Figure on the right shows the final map generated after the execution of S-Graph Plus on T11 experiment. To conclude, we present S-Graph Plus, a 4-layered optimizable factor graph consisting of keyframe, walls, rooms, and floor layers, continuously optimizing this 3D scene. We present a novel room and floor segmentation module to extract this high-level scene information. We validate S-Graph on sim, real construction side, and standard datasets. And we demonstrate that S-Graph Plus outperforms its baseline by a margin of 10.6% on average, providing a richer robot situational awareness through a richer scene mode. Thank you for listening.